All right. So sorry, everybody. Good morning, good afternoon, good evening. It's good to see you. I am so sorry for the delay. That's all my fault. But let's get the show underway. We have very little time and so much to discuss, so let's get to it. Uh, my friends, we're going to talk about Spring Boot 3. Why should you listen to me? Well, my name is Josh Long. I work on the Spring team. A Spring developer advocate, a Kotlin Google developer for the Java champion. And most importantly, I'm at your service. So, I'm online if you need me. I have a YouTube channel. You should join me there. It's fine. What else could go wrong? It'll be okay. Yeah, and in my estimation, somebody who's worked on the Spring team for 13 plus years, in my estimation, if you look at this new release of Spring Boot, Spring Boot 3 came out last November, it is the most important release of Spring in the history of Spring. And I say that fully aware that there have been, 20 years of Spring, right? This is a nice little animation that you can play with, spring1.io/history of Spring, that looks at the history of Spring, Spring Framework, Spring Boot, Spring Innovation, all that stuff, and gets us to this point, right? We have 20 years since the early access releases of Spring Framework, and 10 years since the early access releases of Spring Boot, and next year will be 20 years and 10 years, respectively, since the GA releases of both of those things, right? So it's just been a long time, and Spring continues to evolve and to become and stay relevant, and you can see that in the new modules and all that. But that's always been true. So why do I say that this release is the most important? Well, it's because it's not just relevant in the space in which it sits, it creates new space. And that's a big deal, right? To be able to define and then succeed in a new context is a huge deal for any technology to do, to jump the divide, so to speak, right? So today we're going to talk about Spring Boot 3.0, the latest and greatest, and so on. And of course, in order to do that, we're going to go to my second favorite place on the internet. My first favorite place, of course, is production. But my second favorite place is here, start.spring.io. And I'm going to go ahead and create a new project using Spring Boot 3.2 M3. That just came out recently, and of course Java 21. My friends, we have a few things we have to worry about. What do we want to name the service? Well, I'm going to call it service, and the reason I'm going to call it service is because I'm really good with names. I get that from my father. He was also very good with names. We had a small white dog, and my father named it White Dog. Now, this dog disappeared after like 10 years. I don't know what happened to him. Maybe he got a job. Anyway, then we had another small white dog magically appear at our front door, and my father named him Two. So I'm not sure if it's Too or Two. Either way, Two. And I thought those are great names, absolutely great names. But my mom, she tells me all the time. She says, "You're very lucky that I named you," and I suppose that's probably true. So anyway, I'm going to call this service, and then I have a choice of what version of Java I want to use. My friends, there are 4 radio boxes here, but only 2 valid choices. You see, in order to use Spring Framework 6 and Spring Boot 3, you must use Java 17 or later. And realistically, if I were you today, I would choose the just released Java 21. This came out 3 days ago, but it is, in my estimation, the single most important release of Java ever. And so it's worth moving there. If you're moving from any of these other versions, don't bother. Just go straight to Java 21. Don't bother with anything in between. Seriously, you'll pay. This will pay dividends. Getting to 21 is a great idea. And so these other choices, then, you might wonder, why are they here? Well, they're just here for the memes, my friends. Just here for the lulz. Just here to find out who makes terrible life decisions. These are never to be selected ever. They are completely inappropriate in every situation. So move onward and upwards, my friend. Use at least the latest and greatest. And judging purely by the version number alone, I think we can agree that Java 21 is almost 3 times better than Java 8. So I'm a big fan of Java 21. Now, my friends, what are we going to do? We're going to build an application with some observability. We'll bring in the web support. We're going to bring in the GraalVM native image support. We'll bring in test container support. We'll bring in Postgres. We're going to bring in the dev tools. We're going to bring in the data JDBC support. And I think that's it. I think I'm happy with my selections there. So we got the web, we got the data JDBC, we got Postgres, we got test containers and dev tools. Good. So what I want to do is I want to create a new project and then get coding as quickly as possible. So I'll go here and I'll open this up in my IDE or not. What happened there? UAO RMRF service. Did they change the zip file? Yeah, they're okay. So unzip service dot, let's see, unzip UAO service, sorry, unzip service. There we go. CD service idea build that Gradle. Okay. Oh, that's interesting. They upgrade. Oh, JetBrains. Hold on. I'm sorry, friends. This is new. This happened overnight. Update all the tools automatically. Okay. Idea. So okay. CD downloads. Service idea. Please. Nope. No such file. Idea. Why? Well, okay. I guess we'll do this the old-fashioned way. So I'm going to open up IntelliJ manually. I don't know. There's some sort of update that has now broken my command line um, switches, which is fine. I'll restore it later. Let's close out all this stuff if it lets me. Still, oh, come on. Stop it. Stop it. Okay, good. Okay, so we're going to open that project and downloads. Build.gradle. Open as a project. Oh, it's so slow. I want my command lines back. Okay, so we've got a brand new project, and okay, stop it. We're there. So what we want is we have a brand new project. It's an application that will have a database. It'll have data access. So we're going to go ahead and start the application. Okay, and it's going to talk to a database, but of course we want to have a database. I'm going to use Postgres, and so Docker PS. Okay, nothing's running, so I want to be able to live that git clone run lifestyle. So I'm going to go here and I'm going to use this source test Java. Okay, source test Java. That's this code right here. It's going to create it's a main method, but it lives in the source test Java source code, and it's got an extra Java configuration bean. This is a test container. This will actually automatically start up Docker image for Postgres during development. So I can run this during development, and I can make changes, and I have this extra database here that I don't have in my production code here. And the benefit of this is that now I can get clone run and start making changes and just move very quickly, very efficiently. I love this because now I don't have to download, and set up a whole bunch of things to get my service running. I don't have a wiki page with 500 easy steps to development. So this is very convenient, but I also want to use dev tools. Dev tools are a great way to do fast reloads of your application by making changes and then hitting Command Shift F9. Well, the problem is DevTools works by restarting the Spring application context. It doesn't restart the JVM, just the application context. That's very quick, unless, of course, you start up a whole Docker image on every single restart. So I'm going to go to my build here, and I'm going to change the DevTools to be test implementation, okay? Like that, and that'll let me have some extra types that are visible. Let's see here. What did I do? Did I break this somehow? Spring Boot, DevTools. Test, oh, capital I. Oh, so sensitive. Okay, there we go. So I'm going to go ahead and I've got that new type on the class path that'll allow me to use this annotation called @restart_scope. I can now start this test code. This is not my production code. I'm going to start the test code. Oh, and the JDK, the hits just keep on coming, my friends. Let's see. Edit configuration. Go here. Choose Java 17 for that. Wait a minute. Oh yeah, it doesn't work in the IDE at the moment, so we just go to command line, Gradle boot test run. Okay, there we go. So we've got this nice command we can use on the command line to start up the code in development, and now we can start making changes. Now we can iterate. So let's go down here, record. I'm going to create a new record of type customer, and I love records, right? I love records a lot. They're very convenient, very nice addition to the language. There we go. So now I'm going to create a repository that manages entities of type customer, and I'll use primary key integer. And I then want to have an HTTP endpoint, so customer HTTP controller, and I'm going to inject the final customer repository like this, and I'll inject that into the constructor. Voila. And this is going to be a simple HTTP endpoint. I hesitate to call it a REST controller because it's not hypermedia, so I'll just use @controller. And I'm going to return a collection of customers. Okay, so return this repository find all. Okay, very good. Okay, so Command Shift I. There's my entity. Good stuff. Now, I have the controller. I need some data in the database. So I'll go here. I'm going to create a new file called schema.sql. Create table if not exists customer ID serial primary key name var car 255. Okay. And I'm just creating some schema that will get initialized, and I want to have some sample data in the database as well. So I'll create data.sql. I'll say delete from customer, insert into customer, name values, and I'll just put some people on the Spring team in the community and so on. Hi, Baruch. Good to see you, my friend. We've got people on the Spring team as well. We've got Stefan and Yushin and Olga and Violetta and Madura and Dr. Sire and so on. Okay, so there's a nice round number. It's 8, and if you divide 8 by 2 and then 2 again, it's still 2. I love it. We're going to tell Spring Boot to initialize the schema like this, and then we're going to hit Command Shift F9. What is the issue here? Source release. What? Oh, okay. Edit configuration. Spring Boot. Is it trying to run this? Like, what is it? Build, recompile. Yeah, why is it doing that? Why does it think it's having issues? Okay, so let's edit configuration. Java 21. Okay, happy? Oh, I cannot wait for Gradle to catch, because Gradle right now does not support Java 21. So you end up doing all these gymnastics to make it work. It's very awkward. Okay, Command Shift F9. All right, Java version. Yeah, I don't know what to tell you. What is this doing? Okay, well that is fine. So why didn't Command Shift F9 do the thing that we're supposed to do? Build, rebuild project. Invalid source release. Actually, I don't care. We have to go. So let's just try this. Command Shift I. Okay, fine. So it's now reloaded. Let me restart the thing on the command line there. Okay, good. And so it takes a long time the first time, because remember, it's starting up this Docker image, right? And you can see it's starting up the Docker image in there. And if I go to my Docker PS, you can see I've got this Docker image there that wasn't there a second ago, right? For Postgres and the test containers reuk process to reclaim dead containers. Okay, so now I have the application up and running. I'm able to make changes. Let's see if we can actually use this, to go quickly. So let's go here and create an endpoint. Customers name, okay, collection of customers by name, path variable string name, return this repository at find. Now I want to do find by name. Okay, so this method does not exist, but we'll just let the IDE do the work here. Great method, voila. Okay, Command Shift F9, go to the browser, customers, great, that works. There's that, great, that works as well. So it's worked. Now we were able to move quickly using dev tools. We're able to do git clone run. Life is pretty good. Now, are we done? Well, of course, this is all pretty stock standard stuff, but remember, even though this is pretty stock standard stuff, we're moving much more quickly, and it's a lot more elegant because we're using modern languages and modern syntax and so on. So I'm very happy with our situation here. That said, it's not like things have stayed still. Certainly not, right? There's a whole host of new capabilities out there in the ecosystem, one of which is AI. And if you were joining us in Las Vegas last month for Spring 1, then you know that we launched a new project called Spring AI, which you can use to add AI to your application, generative AI. So I'll paste this here and add this snapshot repository to my build. This is an experimental project at the moment, and it requires a key that you have to specify. Now, I've already got the key as an environment variable, but if you wanted to use it, you would have to say Spring AI OpenAI API key, okay, and then plug that in. You'll forgive me if I don't leak that particular credential, okay? And what I can do is I can use that to work with AI, basically. So let's try that out, okay? So response body class jokes controller, and I can say get mapping jokes, and I can say map string. And right now I'm in San Francisco. So let's see. So I can say whatever AI. Let's try that AI, and I can say story, and I can inject now the AI controller, or sorry, a client. Okay, here's this client. Very good. and I can inject that into the constructor like so, and I can say, okay, tell me a story. This dot client dot generate. Tell me a story about a Java developer in the lovely city of San Francisco. Okay, and I'm just going to ask it to tell me a little story. Uh, um, oh, and I also wanted to do it in the style of Dr. Seuss, who's a book author. Okay, for kids. Okay, so we'll try that out. Command Shift F9. Go to the command line here. Localhost AI, and then we just wait. Okay, we're gonna let that do its thing. Come on, go go go. It's taking its time. Talking to the cloud. Mm-hmm. 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 Still thinking. Still thinking. There we go. Once upon a time in San Francisco's Haley Bay lived a Java developer, let's call him Jay. With his trusty laptop and a cup of joe, he coded away with a cheerful glow. In the heart of the city where the fog rolled in, Jay sat at his desk, a wide, happy grin. He wrote lines of code, made algorithms sing. With each line, his Java skills took wing. So you do get the idea, right? Now, the problem, my friends, is that that took a long time. And during that time, I was blocking, right? This call is a blocking call, which means that the thread on which I'm handling the request is effectively, it's stuck, right? And so what I want to do is I want to be able to take advantage of a new feature in Spring Boot 3.2 to support virtual threads. Okay, so you run the build with this enabled on Java 21. Unfortunately, I've disabled source compatibility, but I'm still running on Java 21. I wonder if that would actually still work. But anyway, it should still work. And what this will do is it'll automatically plug in task executors or executors wherever possible that use virtual threads. So even though it's blocking from the perspective of the client, we're not sitting on a thread wasting that thread on the server side, right? Now we have a lot better scalability. This is a feature that will be available in the GA version of Spring Boot in November. It's early milestones at the moment, okay? Okay, so we've got an application. We should take care of a few things. We might want to have observability, right? We might care about defensibility. Let's say I say that this name has to start with a character 0, right? Character has to be a capital letter. So character dot is uppercase, and then the name must start with a capital letter. Okay. Now, what happens when that exception is met? What happens when it's thrown? Well, it's going to throw an illegal state exception, and I want to have a single place in my code base to handle that error. So, error handling controller advice. Create an exception handler, and I'll handle this exception. And I want to create a consistent representation of the error. I'll use a standard here called problem detail, and I'll inject the bad request value, and I'll say return PD, and I'll say pd.setDetail isc.get localized message. All this is very convenient because it gives me a standardized way to represent errors across my application, and that's very convenient. So let's try this out. Okay, so curl HTTP local host 8080 / customers capital Josh. That should work just fine. What about lowercase Josh? Let's just type that out. There you go. I get the problem details representation of the error. Okay, so I've got problem details. Now, what about observability, right? Or actually, what else could I do here? Well, one thing I might want to do is I might inject the current servlet request, right? Like this. I can say request get header names is iterator for each system out print line. Okay, Command Shift F9, voila. And there we go. So now I've got the updated thing, and I can make the call, and I go to the console here, and you can see I've got the new headers. That's who cares? That's not all that new or interesting. But let's talk about this. This is our old friend. Our old friend has moved homes. It no longer lives in the old namespace. Now it lives in the capital of Indonesia, Jakarta. And to understand why that it is, we need to cast our mind far, far back, a long time ago, before the COVID pandemic, or BC. And during this time, Oracle just stopped paying attention to Java EE. They just gave up overnight. They didn't send any emails. They didn't tell anybody why. They just stopped very rudely. And as a result, all the JCP specifications, which required their continuous input, just came to a crashing halt. Nothing happened for months and months and months and months. And eventually, Oracle were forced back to the negotiating table just long enough to agree to open source, to make really open, truly open and safe for the community, these Java EE types. But they had a requirement. They said every change has to be in a new namespace. So the project now at the Eclipse Foundation decided, okay, we'll move everything to this new package called Jakarta. And they did a very good job, the Eclipse Foundation. But this still is kind of problematic because it means that all the code that you've ever written against the standard will no longer compile, right? When you upgrade to Spring Boot 3, everything from the last 20 plus years is now completely broken, thanks to Oracle. So you just need to be aware of that. It's not that big a deal because they didn't really introduce any other features. All they did was change the package. So it's actually a fairly smooth upgrade path. Okay, my friends. So we've got the new Jakarta EE types. We've got error handling. What about observability? Well, let's say I want to capture information about this exchange here. Well, I can use the new observation API. This is a unified API to capture both metrics and traces, okay, in Spring Boot 3, and it's part of micrometer. So I'm going to add this as a constructor argument. I'll hit refactor, move that up there, okay. Voila. And now I'm going to say this dot registry, and I'll say dot observe, and I'll pass that there. Good. Command Shift F9. And now I want to see all that information as well. So I'm going to enable the actuator endpoints, okay, and I'll show details always. Enable the Kubernetes probes always. Okay, good. So now I go back here and I go to the console, localhost, actuator. Great, all that kind of stuff is there. I go to the metrics, I don't see our metrics. So let's drive some traffic, okay? Do curl HTTP localhost 8080 / customers. Hello, customers. Josh, done, okay, voila. Okay, now I go here and you can see I made a bunch of requests that got captured by this metric. I made 70 requests. It took a total for all of them combined as of 0.3 seconds, etc. Great. Okay, so now we've got lots of data. We're able to do observability. Let's talk about getting this thing to production. My friends, it's very important to remember, I think that when we think about production, there's two kinds of packaging. First is how do you package it as a Docker container? That's easy. Use build packs. Build packs are a great way to take an application artifact and turn them into a Docker image, an OCI image. Remember, friends don't let friends write Docker files. So that's the first thing. The second thing is, how do I make it so that it's as efficient and fast as possible? And here, my friends, it's very important to remember that Java is already very, very fast and very, very efficient. I love Java's performance. I think it's just an amazing thing. And it's also very efficient. And there's this great blog from many years ago that asked the question, which programming languages use the least electricity? If you scroll down here, there's this amazing table, and it has a normalized global results for energy, time, and memory. And you can see, my friends, that, of course, C is the most efficient, very important here, by the way, most efficient for machines, not people, definitely not people, but it's the most efficient way to run things for machines. There's also Rust, zero cost abstractions, doing quite well, good stuff. We've got C++, disgusting, moving on. And then we got Ada, but nobody uses that. So then we have Java. My friends, Java, let's just say simple math, okay? 2.0. We're going to round up so we can keep it in our heads. Very easy. 2.0. And then we look at the list. And by the way, 2.0 means that it's basically 2 times as inefficient or less efficient than C, okay? And then we scroll down the list and you can see things like Swift. You know, if you're using an iPhone, here's Swift. You've got C# from .NET. You've got Go. You've got JavaScript and TypeScript. I don't understand, by the way. How is this? Look at that. TypeScript is 4 times worse than JavaScript. I don't even understand. I thought this compiled into that. How is that so? Then we've got these disgusting languages. I won't even mention them. And then we've got JRuby and Ruby. My friends, JRuby is Ruby on the JVM. Ruby is Ruby in C. By writing it on the JVM, you're almost like 33% more efficient than the C implementation. I mean, truly mind-boggling stuff. The JVM is an amazing piece of technology. And then, of course, we've got Python. And I love Python, friends. This hurts me to say this. It hurts me because I love Python. I've been using it since the 1990s for 23 plus years, 24 years almost. And to understand why, you know, it hurts me to say it, but look at this. This is 76 rounding up, right? And I'm not very good with math, but you know what is very good with math? Python. So let's ask it, okay? We'll say 76 divided by 2, it's 38. That means if I write a Java program and then that Java program creates electricity, which goes into the ozone, it uses a factory which creates pollution, which goes into the ozone, and then that pollution kills one tree, then the same program in Python will kill 38 trees. That's ridiculous. That's like a whole forest of trees. We need to do better. I don't know how we can fix that, but it's something we should talk about. Okay, and this is particularly problematic as we move to the world of AI and all that stuff. So yeah, it's a question we need to have and a discussion we need to have. Okay, moving on. So we've got now our application. I think we can agree that the JVM is already really fast. That said, I think we can say that it is really fast and really amazing for two reasons. One is the Java language garbage collector. Now, I love the Java language garbage collector. It is an amazing piece of technology that lets me write mediocre code and sort of get away with it. That said, I don't think it's fair to say that it is the original Java garbage collector. I think that honor probably goes to someone else. Maybe this person. Her name is Jesselyn. She lives in New York City. She is from the island of Java, Indonesia, and she is a Java garbage collector. So I think maybe she should get the honor of being the first Java garbage collector. I don't know. Maybe not. Who knows? What I love about this, though, is that there's 19,000 people that like this tweet. That's great. The internet is basically terrible, but sometimes you get great tweets like this that thrive and survive. Good stuff. So, okay, the next reason that the Java language itself is so amazing is because of the just-in-time compiler, which adaptively compiles our code into native code. But what if we could turn the whole thing into native code? And of course we can, right? You know about GraalVM. GraalVM is an OpenJDK distribution. It supports native images. And there's just been a new release that came out on the same day as Java 21 for everybody else, for the JRE. Well, the problem with this is that it requires a lot of configuration to account for things like reflection, serialization, JDK proxies, JNI, and of course, resource loading. So all this stuff frustrates the GraalVM native image compiler. So you can provide configuration, JSON configurations. There are two problems with JSON configuration. First, I don't like saying JSON. It just sounds stupid. I can't take anybody seriously when they say that word. So as a French speaker, we say JSON, which sounds, I think, a lot cooler. So that's better. Or if you're I was just in Taiwan, in Taipei, and they have JSON, which is like happiness, right? So that's a nice word too. Either way, much better than JSON, right? So I am team JSON, but you can do whatever you want, okay? That's the first problem. The second problem is there's just a lot of it required. Think about all the places that do this in your code base. Logging libraries, testing libraries, data access libraries. Everything does something or all of these things. Something, many, or all of these things. And so I want to let somebody else do that work for me. Thankfully, Spring Boot now has a new AOT engine. So I'm going to do that here. I'll kick off a native compile, and it'll do the work for me. So we're going to let it compile. The problem is, my friends, that this will take a long time, and it's really quite frustrating how long it takes. I get very bored very easily, very quickly, and so this is very hard for me to deal with because it's just so boring. But it's also so long. It's long enough that I get stuck and I can't do anything useful, but it's not long enough that I can like go do something else. I can't like write an email or take a walk or make a cup of coffee or something, right? So it's unfortunate that I now understand this classic XKCD cartoon that asks the question, what is the number one excuse for legitimately slacking off? Oh, my code is compiling. The boss says, hey, get back to work. No, compiling. Oh, okay, keep going, right? I get that cartoon now. I didn't want to. I thought that was just for the C++ people, but here we are in a weird world, and I get it now. Oh, it's so annoying. Okay, so that's tedious. And the problem is I just get bored. I start to hear theme song music, like from game shows or from elevator music. You know, the music they play when you're in an elevator just waiting to get to your floor. That's called elevator music. And I start to hear it in my head now. And I said, gee, wouldn't it be nice if everyone could hear elevator music? So I went to Oracle and I said, oh, hey, Oracle, please play elevator music during the native image compilation process. And I said, I already hear elevator music in my head when I do these long-running compilations. I'd just like everyone else to hear it too. And I got this response. And by the way, I said, thank you in advance, and I appreciate your amazing work. And I do, I really do. And then I got this great response. I said, from Andrew Din. He's one of our friends over at Red Hat. He's a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, Byteman project lead, and a Growl developer. So clearly, this thread was a great use of his time. And he said, please, can you make it this elevator music? And then he linked to the soundtrack for the Nintendo 64 video game called for James Bond, for the James Bond movie GoldenEye in the 1990s. And it's really good. There's actually elevator music in the soundtrack. I didn't know. So I like that. Somebody else said I would add that using beeps in general, not only for native image, really helped me to reduce development time, which is, yeah, like that's a great idea, right? It makes a lot of sense. My stupid microwave will beep when it's done. Why can't my compiler? That makes a lot of sense. I support this feature. And then I got a great response here from our friend Fabio Niephaus. He's a researcher on the Graalvm team in Oracle Labs. He's a doctor, and he's really well placed to answer this question. He says, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making Graalvm native images more efficient in terms of time, memory, and CPU consumption. Anyway, he continues, I have prototyped the -- Josh Long mode. So let's take a look at what that would do. So the idea is you'd run native image, right? Native image -- Josh Long mode. It would print out music brought to you by Josh Long. I'm Josh Long. That's what's happening here. You would also hear music. It's a picture, my friends. You're seeing a picture. There's no sound, but imagine, okay? Just imagine music in this prototype, okay? But you're still bored. You're still waiting. You want something nice to look at. So then it would print this out, right? I think that's great. I think that would be the feature that we want in our compilers. I'm sure it'll get merged any day now. I don't know what's happening, but I'm sure it'll happen soon. So anyway, what were we talking about? Oh, right, the compilation. Yes, I completely forgot about it. So let's see here. Yes, it finished after 1 minute and 22 seconds. Go to the native compilation here. There's the binary, all of it, right? There's no JRE required. That's everything. I can run it, but of course we have a problem. The address is already in use. Okay, so let's. Where did I run it? I ran it over here in some other shell, right? Yeah, here we go. Close that. Okay, now run it again. And you can see it says we don't have the credentials for the database, right? I use test containers, so of course it doesn't, but that's okay. I have a little script here, run.sh, and what it's going to do is it's going to export environment variables for credentials and then run this binary. So let's just, there you go. There's the application. I have to do docker compose up, and then cd desktop talk run. Okay, there we go. So there's the application up in 0.15 seconds. Everything is there as it was before. So we're off. We got a service. Now I want to build a client. Since we have 4 more minutes, I want to build a quick client here. And I'm going to use the reactive web support. I'm going to use Gateway. I'm going to use GraphQL, etc. And we're going to open this up in our JDK or in our IDE. So cd downloads, unzip client.zip, go to IntelliJ, file open, downloads, client, build.gradle, open as new, this is unbearable. How do people do this? I need my command line thing back. Okay, so it's an edge service. It's a backend for a front end. It's a gateway. Okay, and so I'm going to run this on a separate port, 9999. And what I want to do is I want to make it easy for edge, for clients, if it's like iPhones or Androids or whatever, to get to my backend microservices. One way to do that is to use an API gateway like this. I'll say return RLB routes rs, and I'll say rs.path proxy.uri http localhost 8080, and I want to send it to the customer's endpoint, don't I? So I want to change the path here using a filter, and the filters are the real power of Spring Cloud Gateway. You could do retries. Maybe you want to support cores like this, like that. Okay, access control, allow origin. Like you can do all sorts of things there to make it so that your clients can now connect to this gateway service and talk to your backend API. So let's go ahead and run this and see what that gets us. Okay. Very good. So it's up and running. Now, maybe that's not enough. Maybe instead of acting on the envelope, right? If I use this HTTP localhost 9999/proxy -v, maybe instead what I want to do is I want to act on the envelope, on the payload, not just the envelope. So I can use a new feature in Spring Framework 6 called declarative client. So customer HTTP client. Here we go. And let me close this and figure out why isn't this running? Okay, good. So I'm going to create a new client, and I just, it's pretty straightforward. I say publisher, reactive publisher of customers by name, path variable, string name. And of course, I've got the problem. I have no customer here, so I'm going to do something terrible, something that you should never ever do. I'm going to copy and paste code here. Okay, very good. And now I've got this interface. I want to tell Spring how to map this to server-side endpoints. Okay, so I'll use this new annotation called get exchange. There's also put exchange and bleed exchange and so on, right? And I'm going to use that to map the client-side proxy invocations to server-side endpoints. And of course, I need to actually factory this thing here. So I'll say web client.builder, okay, and I'll say return HTTP service proxy factory dot builder web client adapter dot for client builder dot base URL. I'm going to provide a localhost 8080 dot build. Okay, and I'm then going to say build and then create client customer HTTP client. Voila. Okay. Now, what might I do with that? Well, I could of course use Spring for GraphQL, or I could just inject it like this, like so. Return. Okay, return args http.customers.subscribe, and then just print out the results when the application starts up. Okay, so let's just reload this. Very good. Okay, so it failed. Why did it fail? Oh, I did the wrong host and port. 8080. Reload. Okay, now you can see it work. There we go. So my friends, we've looked at a number of different features here that you can use to build effective, scalable microservices using Spring Boot and Spring Framework and so on. We looked at new opportunities like GraalVM native image compilation, looking at AI, looking at the Git clone run test containers and Docker Compose support. We looked at native images. We looked at virtual threads and the unparalleled, much vaunted scalability of Project Loom and Java 21. We just looked at a few of the amazing features in the Spring ecosystem that I hope will make your journey to production all that much more productive and efficient and fun. I want to thank you so much for your time today. I wish I could be there in person. Obviously, we all do. We're rooting for you. So. Thank you for having me again, and I am very, very sorry again for having been so very late.
It's okay. Thank you, Josh, for joining, and I'm glad that you've managed to deliver the talk. So really great to have you. And yeah, for sure, we hope to see everyone offline in
Oh,
Kiev the next year.
soon. Please. This
Yeah.
is the worst. Um, I am off to the airport. I have to get on a flight for Singapore in about 35 minutes. So thank you, everybody. Send me messages. I'm on email, josh@joshlong.com. Bye.
Thank you. Have a safe flight.